Okay, so day one of free fall. Not getting into projectiles yet, but we'll go to full screen here. Okay, so like I kind of just indicated, come on, you little thing. Okay, so first thing, any object that is being acted upon only by gravity is said to be in free fall. So I'll give you an example. Even though I've been skydiving before, even though I jumped out of the plane, was I falling straight down?
No.
No, because what gave me a little bit of forward velocity? The actual plane. Like if I'm moving with the plane, I jump out of a plane, I'm going to continue moving in that direction, but I'll show you what that looks like when we talk about projectiles. But I'm said to be in a state of free fall. Now, is gravity the only thing that's affecting me?
No, it's also
Yeah, it's this thing called air resistance. Okay, for this class, we're not going to talk about air resistance because it gets a little messy, but in reality, there is air resistance when something is in free fall, and it messes with the calculation a little bit. But for us, we're just going to say no air resistance.
Wouldn't that also deal in aerodynamics?
What's that?
Wouldn't that also deal in aerodynamics?
Yeah, that would deal with aerodynamics. And if you get into AP physics and that sort of thing, and calc-based physics, you can talk a lot about real-world physics, and for example. Okay, so two characteristics that we have to remember for this class. Okay, two characteristics in our class. Okay, one. We'll just say for this class, objects do not encounter air resistance. But let me tell you, I jumped out of an airplane and I encountered a lot of air resistance, right? So there was a point at which I didn't go any faster. Anybody know what that's called?
Incorrect.
It's a fancy word. It's called terminal velocity. Basically, the force of the wind is so great against my body that I can't go any faster, so it's my max speed, right? Now, I can change my terminal velocity by, like, when I'm falling, doing this, or pencil dive or whatever. If I reduce my surface area, I can go faster, but there is a terminal velocity for every object. Okay, the second characteristic that we're going to use, and you're going to get to know this number really, really well. Okay, all objects accelerate due to gravity, and we're going to kiss at do I want to say, let's say at 9.8 meters per second squared down. So which way does gravity always pull? Yep, perpendicular with a flat surface, right? So downward. So since I'm going to be out and I couldn't do my normal first activity, the first activity we're going to do is first determining what gravity is. Because I just kind of gave it away, it's an acceleration, which means objects go faster and faster as gravity pulls on them, right? It's not a constant speed, right? And it's a fairly large gravitational pull. Okay, gravity's very strong. That's a good thing. Okay. All right, I'm going to draw a little picture to indicate what this means. Can I go to right there? So let's imagine myself, I'm on a cliff here, don't worry, I'm going to drop a ball. Okay, I'm going to drop a ball, and if I...
That's a ball.
No. I'm just saying I'm dropping a ball here.
Oh, okay.
Okay. Okay, and this is the ball at 0 seconds. Let's just say this is my 0 second measure. Okay. All right, and I create lines, and I create a ball after every second. It's going to get further and further apart. So I'm going to show this. So after maybe 1 second, it's right here. After 2 seconds, since it's speeding up, it's going to get further away.
Kind of like when you make a flip book.
Yeah. I got to go up a little bit here. Yep, and then the last one is the furthest apart, right? So there's the ground. Each of these is a second apart. But what does that show us? It shows us that it's speeding up, right? Oh, I'm sorry. 2 seconds. After 3 seconds. 4 seconds. And then obviously down here we're going to have 5 seconds. And then what if I went a step further and I said, what is the speed after each second? Okay, after 1 second, how fast is it going to be going? If my acceleration is 9.8 meters per second squared, it means every second it goes 9.8 meters per second faster. So, after 1 second, it's going 9.8 meters per second. And then if I add 9.8 meters per second to that, what do I get? 19.6 meters per second. How about now? 28 point what? 28.3 meters per second. Okay, and then I just keep adding 9.8. I just keep adding 9.8 every second. That's what gravity is doing. That's what an acceleration is if you're still confused from the first unit. Okay, it's getting faster every second. Yeah.
I'm gonna ask you, like, you know how, like, when you throw a ball up, would it go slower, like, as it's going up, or would it go faster, like it's going down?
Yeah, I will give you some examples like that. So yeah, if I throw something upward, which way does gravity pull?
Yeah.
Against it. So yeah, it slows down, slows down, slows down the same way, and then it starts to fall again, speeds up, speeds up, speeds up. But I'll get into that. Yeah. So, I hope you didn't think the graphs were gone. Okay. The corresponding graph for what we see above would be the following here, okay? So if I've got a P graph, a B graph, and an A graph, you could probably, if you really did well on the test, tell me what each one would look like. So if I'm dropping it from a high position, okay, it starts slow, flat, and then it picks up speed as it falls. If I were to show this, how would I show that? Which way is it dropping? In the negative direction, right? And it's speeding up in the negative direction. And then my acceleration, negative 9.8. Yep, negative 9.8 would be my acceleration. Remember, if I found this slope, that slope would be negative 9.8 meters per second squared. And that is directly correlated to my acceleration over here. Any questions on this so far? We're almost done. Okay, so now we're going to calculate Remember, we're starting off since it's kind of fresh in our heads. How do we calculate this stuff now? It actually becomes easier in free fall because free fall gives us a couple things right off the bat. Okay, if something's in free fall, what's the acceleration always going to be?
Negative 9.8.
9.8, right? Negative 9.8. Can I take this away? Okay. So luckily our equations are the same. Remember, we're going to have VF equals VI plus A times T. Nothing changes there. X equals VI times T plus 1/2 AT squared. And then VF squared equals VI squared plus 2AX. Nothing changes. And then what makes it easier is that A is always, let's see, what do I want to do? Do I want to say a negative? Okay, what do you think a negative 9.8 means here? Yep, we're saying that that negative means it's in the downward direction. Does that make sense? Okay, so up would be what?
Positive.
Yeah, so up equals a positive. Okay, so like we'll do examples like Najib said, like if I throw this ball up at a certain speed, that velocity must be positive, okay, but my negative acceleration makes it stop and come back to me, right? Luckily, because if it didn't happen, we'd be all floating around everywhere. And then one more thing that makes it easier. Okay, one more thing that makes it easier. Most, not all, most free fall problems VI equals 0 because they say it's dropped, right? But if it, for example, says I throw it up, I got to give it initial velocity of something. Right?
What if you jump?
What?
What if you jump?
What if I jump? I'm getting a positive velocity, yes. Alright, all we have left are examples. Okay, you people on the video, you make sure you do these examples, because last time you didn't do them. Okay? Okay. Example 1. Remember, everything that we do here is going to be in a word problem format. Okay, Luke drops a pile of shingles from a rooftop. .52 meters above the ground. Okay, determine the time it takes for the shingles to hit the ground. Now, a little bit different from the first unit, I only see one number. Okay? I only see one number, 8.52. Okay, still be in the habit of this. Okay, so VF VI, A, T, X. This is really going to come in handy when we start talking about projectiles, where we're in 2 dimensions. Okay, so first of all, what is my 8.52 meters? Huh? Meters is giving us what? A distance. Okay, so this is 8.52 meters. That's all they give me, yes or no?
No, yeah, negative.
Yeah, well, yeah, so A is always a negative 9.8.
And then the initial velocity is 0.
Initial velocity is 0 because I dropped it, right?
Yep.
Okay, so I have 3 things. I can do something with that. And then what do they ask me for? I want to know the time. Do I have VF? Can I use the first equation? No. I don't have time though. Oh, so yeah. In this case, let me just write them out so I don't get any confusion. So, can I use my first equation? No, I don't have VF. Okay, and they give me X, and I should probably use X. Okay, can I use this one? I have X, I have VI, I have A, I can solve for T, yes? Bingo. So, huh? Yeah, but what's my VI?
0.
Yep, if my VI is 0, my VI goes away, or my T goes away. So I'm going to put my information in for the second equation. 8.52 equals 0, so it's 1/2 times a negative 9.8, okay, times T squared. Okay, what do I do first? I got to do 1.5 times 9.8, right? So I got 8.52 is, oh gosh, half of 9.8 is 4.9. So I've got a negative 4.9, right? It's still times T squared. Now what do I do? Sean, what do I do here to get T by itself? Next step.
I'm not good at math. I don't know why you asked me.
Pre-algebra.
I have an F in math.
Divided by
Algebra 1.
divide by negative 4.9. Pull out my calculator. Omer, do it for me actually. 8.52 divided by negative 4.9. Yep. What? 1.738. That's a negative, right? Is equal to T squared. Uh-oh. What happens when I try and square root a negative? You get an error message. So guess what? We're going to break the rules of math. Yeah, because you can't have a negative time, right?
And then you can put in the negative after, right?
You sure can.
But it's just going to be the absolute value of time. There's no such thing as a negative time. So, yeah, I'm going to square root a positive 1.738. Omer, what do I get? Huh? Yeah, 1.3 seconds. Okay? 1.3 seconds. Square rooted my 1.738. Okay? Whoa. So, not much different than the first one, or the first unit. Okay, so everybody on the video should be able to do your practice now. You must show your notes to Miss Patty in order to get your practice. Okay? Come see me if you need help.